So we're going to talk about a bunch of understanding stuff, and we're going to look at some sort of formulae before we get into the actual doing of this. So there's going to be kind of a bit of a setup, but we're going to do a lot of writing. We're going to talk about a lot of stuff. So make sure that you understand what's happening before we move on. There's a lot of little ideas to this, and again, they are very accessible and straightforward. But that doesn't mean you'll be able to figure it out on your own. In fact, this is something that would be incredibly hard to teach to yourself, don't you think? Because it's brand new. And this is, again, I've been telling you all year, like grade 10 is such an important year. You learn so many interesting things for the first time, like factoring and parabolas, drawing anything more than a straight line, right? And linear systems, oh my goodness, that's a huge step into a new world. And then finally trigonometry, which is like this giant branch of mathematics. And we're going to see it for the first time here. So this is the last like big introduction, and it's really, really interesting stuff. In grade 11, and if you take the functions class grade 12, it gets so interesting, and you see trig from so many different directions, and it just, everything ties in together. It's really, really interesting. There's just a lot going on here. But it's also quite straightforward, so it's really nice that way. So what do we know about right triangles? It's a triangle with a 90-degree angle. What do we know? What can you use, but you can only use in a right triangle? It's a bit of a weird question, but right, Pythagorean theorem. So we're already familiar with this idea that there's a formula that's a great formula and it's very useful, but it only works in right triangles. So what we're going to learn today and what we're going to do for next week is exactly the same. It only works in right triangles. And then when we come back in January, we're going to learn something that works in non-right triangles. And if you tried to use this, it wouldn't work. Okay, so that's part of this unit, is knowing what to use when. But for now, everything you get will be a right triangle, so there's no worry about that. So there are three ratios, or they're kind of like a formula. Okay, so I often call them ratios, but when I say that, I mean formula. Okay, and so here they are, and we need to know these for everything we do. So I'm just going to write them down, and then we're going to talk about them. So there's the three ratios. Okay, you can write them down. You already know some of these words. Well, you know what the word opposite means, but we don't have any context for what it's referring to yet. We will in a few moments. Same thing with adjacent. You know what that word means, although it's an interesting word. Everybody kind of like, yeah, I know adjacent. And then if I ask you to define it, you'd be like, well, how would I describe adjacent? So it's a weird word that way. But anyway, you've all heard it before, I'm sure. And then hypotenuse, we all know. Hypotenuse is the same as the hypotenuse in Pythagorean theorem, so that's awesome. We already know hypotenuse. Just for reference, oh my goodness, that word is not sin. If you say sin, you're just going to drive me crazy a little bit every single time you say it. Okay, so it is actually sine. That's how you spell it. This is a short form, sine. Cos, and if you say cos, that's okay, I won't be angry. Actually stands for cosine. And tan, which again, you can say tan, but it actually stands for tangent. Those are the words that they stand for. Oh, and one more thing that I should mention here is that symbol, I shouldn't use equals, that symbol is theta. And it's a Greek letter, and it's one that we often use, so it's commonly used, as an angle. So theta and you're going to understand this once we get into it. Okay, you're not going to quite be able to visualize it yet, but you will eventually. Theta is just a very normal variable. Like we use x a lot in the last unit. And we use x for graphing, and we use m for slope. theta is like the kind of standard variable we use when we're talking about angles, okay? So that's theta. So these are all, you can see how it's a ratio. Opposite over hypotenuse, opposite over adjacent. Those are ratios. Those are side lengths in a triangle. And we'll see that afterwards. So it's a ratio of one side length to another. Okay, that's what's going on there. Okay, so what do we mean by opposite, adjacent, and hypotenuse? I'm going to draw a triangle here. It's really hard to draw on a computer, but I'm going to try to make it look nice. That's okay. There's a right angle. You should probably use a ruler to be drawing these things. You're also going to need your calculator. So if you don't have it out, get it out. You're going to need it in a few minutes. When you get it out, take a look. Like you've got 3 buttons on your calculator: sine, cosine, and tangent. Sine, cos, tan. If you don't, you need to throw your calculator in the garbage and get a new one. But it has been a few years since I've seen anybody with a calculator that doesn't have sine, cosine, and tangent on it. So probably we're all good. And you guys tend to have good calculators in here. So we're going to learn how to use those buttons. You cannot do this math. Like there basically isn't a way to do it without a calculator, without those buttons. You're like, oh, just show me the other way. No, there is no other way. Like there really isn't. Okay, so you have to. If you forgot your calculator for the test, you'd be done. Like they wouldn't be able to do it. Okay. So everybody got that? Okay, so we all know what the hypotenuse of this triangle is. How do we identify the hypotenuse? It's across from the right angle. That's still always true. So I'm just going to put a theta in here and say this is theta. Is the measure of this angle? I hope you know what a measurement angle is, right? It's how far one side length is rotated away from on a pivot point, rotated away from the other. So a bigger angle is rotated more, smaller angle it's rotated less. I hope we kind of all understand that. And so what are opposite and adjacent? They're side lengths. Does anybody want to guess? Like what of the other 2 side lengths that are left would you think is the opposite side length? Vertical or horizontal? Why would you say that? Okay, fair enough. Tony, what do you think? It's opposite the angle, so which one is it? The vertical one. So I'm going to draw an arrow across from the angle theta, and this one is opposite. It's the only side length that's not touching the angle that we're talking about. Notice the other 2 are forming the angle. This one's opposite from the angle. If you need to draw an arrow, at least for now, until it clicks for you, do that. Draw an arrow across the triangle to find the opposite. So the last one must be adjacent. Whoops. What does the word adjacent mean? Does anybody want to try to define it? Anang?
You're standing in the middle of a circle, and there's a circle of people around you.
Yeah.
They're all adjacent to you.
Yes, sort of, at least. Okay, I see where you're going with that. Anybody want to add to that? Adjacent? That's a weird word. It means like next to, right? Like adjacent, like beside, like maybe touching or like next to, right? Like side by side, something like that. So we do shorten these words. I wrote them out in those original ratios, full words, but we don't typically write them. So we usually write them like this: HYP, OPP, and ADJ. And please, guys, please don't shorten them further. Some people like to get really lazy. They're already shortened. That's how we write it, though, okay? Don't shorten it any further and say opposite is called O or something like that. Okay, when you're writing formulas, I mean. You're going to see what I mean in a minute. Okay? Notice something very interesting. Each one of these things is in relation to the angle. So I put the angle theta there just because I chose to put it there. What would happen if I moved the angle up there? Riley, what do you think would happen? Very good. That's a bit of a tricky concept that fools people sometimes. Most questions, this doesn't happen, but once in a while you're solving, you have to switch the angle, and then your side switch. So like when you again, this will be more clear when we actually start doing these questions, what exactly I'm talking about. But if I switch the angle, opposite changes. It's related to the angle. This is not opposite to that angle there, right? So we've labeled this because theta is there. But if you had to move theta, you'd have to relabel the triangle. Not hypotenuse, it doesn't change, but the other ones do. Okay? So I'm going to write out one more time. Sine theta is opposite over hypotenuse. So sine is a button on your calculator. Sine of the angle equals the length of the opposite over the length of the hypotenuse. That's the relationship. Okay, cosine is adjacent over hypotenuse, and tan theta is opposite over adjacent. So that's how we would typically write them out. And there is a mnemonic device. So that means like a memory device, like this little trick that we use to help us remember these three formulas. It's really easy to use. Once you've used it a few times, you'll never forget it. Does anybody know what it is or ever heard it? Like ever heard a special word, something to do with trigonometry? Sometimes people have heard it before. No? Okay, I'm going to spell it for you. That's an H. Sohcahtoa is how you say that. Sohcahtoa. If you went anywhere in the English-speaking world, anywhere around North America or anywhere, and you asked somebody who's taken grade 10 math before, or sometimes the grades change a little bit, and you said the word Sohcahtoa, they would know what you mean. It's super famous. Everybody knows it. Everybody who's in grade 11 or grade 12 at the school would know what Sohcahtoa is. And now you do too. Part of a very elite club. Okay? So Sohcahtoa. I had a couple of instances in my career where people, where like we always use Sohcahtoa, and everybody's like, Sohcahtoa, it's great. It makes life so easy. And then I had one kid one year say like, yeah, Sohcahtoa is great, except I don't know how to spell it. So it doesn't. If you don't know how to spell it, it won't help you. So I don't know if you can't learn how to spell it, then that's tricky. You have to learn these formulas another way. But you do know how to spell it. You can't change it. It's sort of phonetic, like Sohcahtoa, right? Like you can kind of pronounce it. And once we start working with this, it'll, I think, be easy for most people as one person, right? But the other thing is I had somebody after like a whole unit of learning this say, sir, I still don't really understand what the point of Sohcahtoa is. Can anybody explain Sohcahtoa? Zakira? Nice. Good explanation too. Sine S, opposite O, hypotenuse H. Right? That's how it works. So if you didn't notice that, like some people don't notice that right off the bat, but it might seem obvious to some of us. Cosine is adjacent over hypotenuse, tangent is opposite over adjacent. But if you like memorize it wrong or spell it wrong, then you're going to say cosine is opposite over hypotenuse. Right? So maybe write it down a few times, make sure you really know it. But it's very helpful. And Sohcahtoa is right triangle trig. Remember what I said. These three ratios are for right triangles only. So when we say Sohcahtoa, we mean we're doing right triangle stuff and right triangle stuff only. Does not work in non-right triangles. Any questions about any of that? Okay, get your calculator out. Yes, Alan?
So, in that rating of triangle, let's say if we have Sohcahtoa and we memorize it, we know it, right? Let's say we have a question.
Okay, we haven't got to the questions yet, so you can't ask, like you got to wait until we learn that before you start asking about what's happening. That's part of the lesson. Everybody got their calculator out? This is still only part of what we're doing. It's like the end part. So you're going to have a triangle. and you're going to do all this setup stuff, and at the very end you have to punch it into your calculator. So we're learning all the stuff, all the little things we need first before we actually even see what a question is going to look like. So I would say in trigonometry, I think it's useful to think about there's 3 different kinds of questions you can end up with. 2 of them we're looking at today, and the 3rd one we're going to look at on Monday. And these are the 2 of the different kinds. So this first one, I would call it like an X on top. So when I've done all of this work and I've set this up, and I notice, oh, this is the one with X on top. So how do we solve with X on top? Well, it's just like an equation. It's just like a normal equation where I'm trying to isolate X. So how do I get rid of the 22? Move it away from the X just by multiplying both sides times X. Does that make sense? So, oh, sorry, not times X. I was thinking about something else. Times 22. I hope you picked up on that was wrong. I'm moving the 22. I'm leaving the X alone, so I want to multiply by 22. That gets rid of this. And this ends up being 22 sine 45 equals X. This is what I mean. Like, make sure you understand this before we move on. X equals. I'm writing in red. Here's where you need your calculator. Oh, come on. I don't know if mine's going to work. Oh, there we go. Okay, so I go 22 sine 45. And do you get 15.55 or 15.6? If you didn't, are you guys like with us over here? Are you guys talking about your calculators? Okay. But pay attention because I'm going to help you with this. If you have a one-step calculator, I would go like this. 22 times 45. Uh-oh, does this even have sine? Oh my gosh, this thing doesn't. Oh yeah, there it is. Sine. That didn't work. Who has I don't know what's wrong with that thing. Who has a one-line calculator? Yes, thank you. 22 times 45 sine. There we go. Oh, you can't really see that. I'm going to do that again. 22 times 45 sine equals, and there you have it, same answer. So you have to put in the angle first, then hit sine, whereas if you had like a proper calculator, you put in sine and then the angle. Yes? Yeah, sure. You're going to miss some pretty important stuff here, though. So make sure you can get 15.6. If you can't, let me know. The other thing that can happen is, I don't know if, oh, you can't see that at all, is if I zoom in a little bit here, see this D? If your calculator's in the wrong mode, you're going to get the wrong answer. There's 2 other modes that you could have. You could have an R or you could have a G. And a nice little test is if I do cosine of 60, that gives me 0.5 or a half. And as long as I get that, I'm in the correct mode. It's a nice little math check that your calculator is in the right mode. But if you just remember D for degrees, you're good. When you get to grade 12, you learn about one of the other modes. Oops. Every calculator is different, so I'll have to, let me see. Oops. Okay, let's move on. I want you to try this one on your own. It's the exact same. B is the exact same. Give it a try. And did you get 0.42 or 0.4? Yeah? Okay, very good. Next one is a type with x on the bottom. So we're going to do this a long way once, and then afterwards we're going to take a shortcut. This is the one where, I have x on the bottom. Folks, all this is, people overthink it. This is no different from in grade 9, you learn how to solve equations. When you have a fraction, what do? You multiply by a common denominator to get rid of the fractions. It's the exact same thing. So I'm going to multiply this by x and multiply this by x, and I get x times the tan of 7 equals 50. But then I want x by itself. Tan of 7 is all one thing. It's not two things. You can't split up the tan and the 7. They always go everywhere together. They're like that inseparable couple that makes everybody else kind of annoyed that they won't stop being around each other constantly. You divide by tan of 7 on both sides. I should show that. Sorry, I'm going to redo that. So divide this side by tan of 7 and divide this side by tan of 7. So the tan of 7 divided by tan of 7, that's like one whole thing, right? So then I get x equals 50 divided by tan of 7. And in effect, notice how x and tan of 7 traded places. So when x on bottom, they trade places and you divide. X on top, just move it over and multiply. But you do want to understand why. Please don't just memorize that. It's an easy way to do it in one step. But you really should know why. Okay, try that one on your calculator. $407.2. Anybody get that? 50 divided by 7 tan equals. Make sure you ask me before you leave today, and I'll show you how to use your calculator if you're still having troubles. Folks, that's where your reflection, your self-reflection, your own personal learning takes place, is when you try questions yourself, and if you get them wrong, you ask about it. That's what was lacking in the last unit, especially during the review part. I think a lot of people didn't go through that process. Okay, try this next one. I got 21.97. Please, please, please recognize that rounds up to 22.0. If you put 22 without the 0.0 or anything else, then you rounded wrong. But the 7 rounds the 9 up to a 10, right? So the 1 changes, and you still keep the 0 when you're rounding to one decimal place. Everybody good before we move on? We're about to get into the good stuff. Okay, write this down. It's really useful to have these steps. I'm going to give you a second to do this. Sometimes when things are really easy, we get lazy and complacent and we take shortcuts, but then we get to a hard question and we don't know how to do it. Or then, we have a 2-week break and we come back and we're kind of like, I forget how to do that. And that's where breaking it down to simple steps really helps. It makes it easier to remember. It makes it easier to move forward when you get stuck. So even though this process is really easy, and some of this work will end up being kind of like, you won't need to do it every time. It's really good to think about the steps, especially in the beginning of exactly what you're doing. Okay? So we're going to talk about it in terms of steps. And today we're just solving for side lengths. On Monday we're going to find the value of some angles. So this is trigonometry. This is right triangle trig, Sohcahtoa trig. This is how it works. Notice in this question, I'm given an angle, 68 degrees. I'm given one side length. I also know the right angle, because this is right triangle trig, so you have to know which one's the right angle. And I'm told in this case, I'm told what I'm supposed to find. That's what the questions look like. It's going to give you 2 pieces of information and ask you to find a third, sometimes a fourth or a fifth as well. Okay? So this is how these questions work. But today, you're always finding a side length. So once we set it up, we're going to have a question that looks like one of these two, x on top, x on bottom. But it's not set up for us yet. It's just a drawing. So here's what we do. Step 1, label the sides. You can do it in whatever order you want. I always do it in the same order. It's just it's just my habit. I always go across first to find the hypotenuse. Then I find the opposite, because I went across once, so I go across again. And then I fill in the blank. The last one must be the adjacent. Again, notice that I'm using the angle 68. I could find the other angle in the bottom left or bottom right there, right? I could solve and find the value of that angle, but that would complicate things. I'm not going to bother. I'm just going to use 68. Opposite from 68 and adjacent to 68. If I mark out this angle, I'm always touching the hypotenuse, and then I'm also touching the adjacent side. And opposite does not touch adjacent. So that's step 1. Label the sides. Labeling the sides is not worth a mark. But if you skip it and start making mistakes, sometimes it's super easy. It's so easy that people think it's too easy. They don't want to do it. But then when they try to transfer stuff into their equation, they make mistakes. So if you make any mistakes doing that, then I say, why not just label them? You could label them. This part you can do however you want. If you want to shorten it and use OAH because you're too lazy to write out the 3 letters, that's fine. It's not worth marks. Do whatever you want. Step number 2. I always like to do this too. I circle the 2 that have something going on. Adjacent is all by itself. It's just blank. Okay, so I'm not going to circle that. So which of the 3, who remembers that word? Rachel, what is it? Sohcahtoa. Which of those 3 things am I going to use for this one? And what do you think? So, which is sine. Why? Because I have opposite and I'm looking for hypotenuse. And that one's got opposite and hypotenuse. Sine theta is opposite over hypotenuse. Write it down with the theta. Write it down properly. Some people at the end of this lesson ask, how do I know which of those 3 to use? But that's what we just explained. I use sine because I'm looking for x, which is the hypotenuse, and I know the opposite length. The only ratio that uses opposite and hypotenuse is sine. If I tried to use this one, I would need the adjacent. If I try to use this one, it doesn't even have hypotenuse in it. So how would it give me x?
Would it be alright if we write that formula every time down?
You have to write it every time down.
No, like the Sohcahtoa.
You won't have to do that, but you can do whatever you want. If you want to write down at the top of a test, if you want to write it down once, great idea. Write it down every single time you do a question. I don't think you'll need to, but you could for sure if you wanted to.
If you had Not every single.
Yeah. You would have some choice. That makes it a bit more complicated. We're going to talk about that a little bit next week. Surprisingly, at least for some people, that makes it a lot more complicated, but you would have some choice. That's right. Okay, so that's step 2. I chose the correct equation to use and I wrote it down. Step 3 is plug in the values. Sine is always of an angle. So that's the 68. If you put a length in there, the whole system falls apart. It makes no sense. You don't take sine of a length. Even if you're looking for an angle, that's not how you do it. Okay? Equals opposite over hypotenuse. That's step 3. Step 4, solve. We've already done that part, right? This is the x on bottom. They trade places. Try it on your calculator. Make sure you can get the right answer. And when you're given units, you always put the answer with units. I got 16.2. Is that right? Okay. See, pretty straightforward, right? Like, it's not a lot of crazy stuff going on here, but you'd be surprised. This is a huge branch of mathematics. Questions? Try another one. If you're the type of person who gets nervous on a test, breaking it down into steps helps. So I don't understand how you could practice a whole bunch of these and get really good at it, and then you sit down at a test and all of a sudden you can't do it. I don't really know how that works. But that being said, let's say you think you understand it. You sit down on a learning goal or something, and all of a sudden you don't know how to do it. If you can say to yourself the steps, well, what's the first step? Identify the side. Well, I can do that. Like, if you can just come up with the steps, you're going to be able to do each individual step. I don't see how you could not work through it. So that's what I mean. When you're doing this, every time, think about the steps. What's the first step? Identify the side. So this is hypotenuse. Which one is opposite? Jaden? Good. And so the last one must be adjacent. So which of the 3 ratios am I going to use? Tara? Yeah, nice. Toa tangent. Tan theta is opposite over adjacent. I feel like there's probably somebody who's like, why are we using that one? I don't know why we're using it, but you're not asking why. Why are we using that one? Because we circled those two. We're looking for adjacent, and we know the the opposite. Hypotenuse has nothing to do with it. Tangent's the only one that's got opposite and adjacent in it.
When you talk about opposites, how do you know that it's not the other way around? Like that one's pointing to that one and that one's pointing to that one.
What do you mean?
Let's say the opposites. How do you tell which one's the opposite one?
It's opposite because I drew it. I went from 20, the angle, and I went to the opposite side. There's no other side in that triangle that's opposite from it.
You go from 60 to 20.
That would be the same thing. It wouldn't matter which way the arrow is pointing, right?
But then which one would you use in opposite 60 to 20?
20 is an angle. So 20 can't be opposite, adjacent, or hypotenuse because it's an angle. Yeah. Okay, so tan of 20, go ahead and you can finish this one, is opposite over adjacent. So again, this is like x on bottom. I know it's y this time, but x on bottom. You done already? Ooh, what'd you get? Yeah. Did you get? Whoop. Did you get 164.8? Who got 164.8? Woo! Let me ask you this. Does that answer make sense? In the last few units, often you could like check your work and make sure it was right. How do we do that with trig? Awesome, great. I hope you guys were listening to that because Tara just gave a great answer. It's really, really good. That's exactly what I would say. This length is, now triangles aren't always drawn to scale. And if you draw it yourself and you draw the triangle all the way wrong, then you can't always do this, right? So it's not drawn to scale. However, that is pretty close to 20-degree angle. Like it's good enough, right? It's not big and it's not really small. So it looks like it could be 20. And this is 60. This is a lot longer. Does it look like it's somewhere between twice as long and 3 times as long? Sure. It's off by a little bit, but it's reasonable. If I got an answer of 50,000 meters, I'd be like, that doesn't really fit this triangle. Or if I got an answer of like 7 meters, I'd be like, how can it be smaller? That's wrong. I've done something wrong. So you can eyeball it. And usually if you make a mistake, usually, not always, it's going to be off by enough that you can tell. Zoe, what were you going to ask?
And if you have a given or using the hypotenuse, you can usually tell because you use the hypotenuse.
Very nice. So that's going to come up a bit later, but the hypotenuse is always the longest. So if you flipped something and got something backwards and you found your hypotenuse was shorter than the other, one of the other 2 sides, you've made some kind of a mistake. Okay, good. Try this one on your own. Start to finish. What are the steps? Step 1, step 2. Did you pick cosine? Okay, good. Keep going. You're not done.
Is it a so in H or in A? So in Sohcahtoa.
Okay, did you get 7.5 kilometers? 7.5 kilometers. Looks reasonable to me. It's less than 8.9 by, a bit. And everybody okay? Yes? So you just type 8.9 times 33 cos equals. Okay, one more example. This is really easy, but it involves a convention that you just don't know yet. So we're going to learn it quickly, and then that's that. And it's a convention that will be very important in January as well. Okay. So we're not given the triangle. We have to draw it ourselves. And like I said before, I'm gonna try to kind of draw it to scale. So make sure you draw a right angle. And I noticed that one of the angles is 47. So what would the other angle have to be? One of them is 90, and 47, what's the other one? Liam? 43, good, yes. So let me show you an easier one. In this one, what would this angle be? 70. You have to add up to 80. This is always right triangles. So 90 is always don't worry about it. The other two always have to add up to 90. 20 plus 70 is 90, right? So same thing for that one, 33, we can figure it out. And for this one, 47 and 43 add up to 90. And they're very close, so I drew two angles that are close to each other. I didn't draw like a wedge triangle, right? Like a small one. So, and this one looks a bit bigger to me, so I'm going to put angle A up here. But if you drew it the other way, you could label it the other way, that's fine. This is obviously C. This one is going to be capital B, so it's triangle ABC. And here's the convention. Where do I put little a, little b, and little c? It's not random. It's not different for everybody.
Isn't it from the a squared plus b squared?
Kind of. No, not really. It will work out that way in this question. C is the hypotenuse, but it wouldn't always be. The reason is big C, big letters are always angles. This is just the convention we use, just our standard. And the little letters are always side lengths, and big C and little c will always be across from each other. So big A and little a, big B and little b. So even if you wrote A in the bottom, you'd get the same triangle. It would look kind of like in different places, but it'd be the same idea, and you'd get the same answer. Okay? So you always have to do it that way. We're supposed to find C and B. Which one do you want to find first? C? So I'm going to use this one no matter what. I'm not going to calculate 43 and use it. I'm not going to bother with that. Hypotenuse, opposite, adjacent. If I'm looking for C, whoops, and I missed something here. A equals 15. I'm looking for the hypotenuse. I know the opposite, so that's sine. Okay, and then I want you to do B. So I got 20.5. Now that, before you get started on B, I know you're kind of scrambling to catch up here, but before you get started on B, I know the hypotenuse now. So I have some choice about how to do the next step. In fact, instead of trigonometry, what could I use to find b? Right? You could use Pythagorean theorem. We'll talk about this more next week, but the easiest way to do it is, if you can, to use givens. Don't use rounded answers. So for now, just you won't need to, so don't use them. We'll talk about it more next week. But I'm still going to use trig, because quite frankly, I think it's a lot easier than Pythagorean theorem anyway. It's less writing, and it's kind of easier to punch in on your calculator without making a mistake. Use the 15 and use the 47 to find b. That way you won't be off. If you use your rounded answer, you'll be off slightly, and we're working towards perfection. Okay, so go ahead and try that. How did we get A? It's given in the question.
We got the angle with the opposite.
It's given in the question.
And then A15 is the opposite to what's the adjacent? What's the adjacent? Is it the hypotenuse?
It's not, the same thing can't be adjacent and hypotenuse. The whole point of it is one or the other.
That's the hypotenuse.
Look.
Oh, wait. B is adjacent.
Okay, did you get 14.0? Any questions?